Welcome. In this session, we'll look at another example illustrating the use of product and quotient rules, one in which I have to use both. I have a problem where I have to differentiate a fraction where the numerator is a product. Of course, I can multiply out the numerator, but we will leave it in that form, just use the product rule to differentiate this. I will start by first writing down what the quotient rule says without doing any differentiation. So it's derivative of the numerator multiplied by the denominator minus numerator times derivative of the denominator over square of the original function's denominator. I've simply put in the numerators and denominators. Now when I differentiate here, derivative of the numerator, I have to use the product rule. So it says differentiate the first factor, in this case 1 plus z squared, that gives me 2z, times the second factor 1 plus z cubed, plus the first factor 1 plus z squared, times derivative of the second factor 1 plus z cubed, so that's 1 plus z squared times 3z squared. Then of course I have this outside the braces. And then in the second term in the numerator I have the original function's numerator multiplied by the derivative of its denominator, that's derivative of 1 plus z power 5, that's 5z power 4, the whole thing over 1 plus z power 5 quantity squared. I can leave it in this form, but I'm going to distribute the 1 plus z power 5 in the first term over the two terms inside, because there are two other ways to do this problem that we can do later, one using chain rule and negative exponent, another using logarithmic differentiation. And given in the last form is more useful to compare the answers from the three methods. This concludes our basic look at the quotient rule, and I will stop here.